What kind of naval weapon can reach speeds of 40 knots while carrying a large-scale vertical launch system? Recently, the domestically developed Orca large-scale stealth unmanned combat trimaran, which previously debuted at the Zhuhai Airshow, has entered the sea trial phase. This marks a transition for the unmanned system, from a display model to a platform with actual combat capabilities, representing a crucial step forward in the realm of independent operations in the open seas. The Orca unmanned combat vessel, independently developed by China's State Shipbuilding Corporation, is a 500-ton medium to large unmanned surface combat platform with fully independent intellectual property rights, representing the pinnacle of China's current unmanned vessel technology. With a total length of approximately 58 meters, a beam of about 13 meters, and a draft of roughly 6 meters, it features an advanced trimaran design consisting of a slender main hull and two symmetrically arranged side floats. This structure not only significantly enhances the vessel's stability and resistance to rolling and rough seas, but also effectively reduces wave-induced drag during high-speed navigation, thereby improving propulsion efficiency. Compared to traditional monohull designs, the tribal configuration maintains a shallow draft, while substantially increasing deck area and internal volume, providing the physical foundation for carrying more mission modules, sensor systems, and weaponry. In terms of propulsion, the Orca is equipped with a combination of high-performance diesel engines and water jet propulsion systems, achieving a maximum speed of 40 knots, far exceeding that of conventional vessels in its class, and even approaching the performance metrics of some high-speed missile boats. With a range of up to 4,000 nautical miles, it can continuously carry out patrol, reconnaissance, surveillance, and strike missions in the open sea for weeks without resupply. This breakthrough in performance has completely transformed the previous situation, where small unmanned vessels were limited to nearshore operations, endowing them with the capability for cross-sea maneuvering and independent operations in the open ocean, thereby truly achieving a leap from a nearshore tool to a far-sea combat capability. Stealth design is another major highlight of the Orca. The vessel features a sleek and streamlined silhouette, with a superstructure incorporating an integrated mast structure. Radars, communications, electronic warfare systems, and other sensors are all enclosed within sloped panels designed to absorb radar waves, significantly reducing the radar cross-section. At the same time, protrusions on the hull's surface have been minimized, and weapon systems predominantly employ recessed or retractable designs, further enhancing all-around stealth performance. These low detectability features enable the Orca to operate covertly in complex electromagnetic environments, effectively evading enemy radar detection and enhancing battlefield survivability. As an unmanned platform designed primarily for combat, the Orca is equipped with a highly modular weapons system. A universal vertical launch system is installed in the midship section. Although its capacity is limited by displacement and cannot match that of large destroyers, it can still accommodate a certain number of vertical launch cells, supporting a mixed loadout of various missiles, including short-range air defense missiles, anti-ship cruise missiles, and light anti-submarine missiles. This multi-mission compatibility allows the Orca to flexibly configure its firepower according to different operational scenarios, enabling it to carry out a variety of missions such as area air defense, anti-ship strikes, and anti-submarine warfare. Additionally, the bow is equipped with a remote-controlled weapon station capable of mounting a 30mm or 40mm automatic cannon to counter asymmetric threats such as small fast boats and unmanned aerial vehicles. The stern features torpedo tubes, providing the capability to strike underwater targets, and forming a three-dimensional air-sea submarine offensive and defensive system. In terms of sensing and information capabilities, the Orca integrates an advanced suite of sensors. A four-phase active phased array radar is mounted atop its mast, providing powerful target detection, tracking, and identification capabilities. It can simultaneously monitor hundreds of air and surface targets, and boasts excellent anti-jamming capabilities and low-altitude blind spot coverage, features extremely rare in small to medium-sized unmanned vessels, and typically found only on 10,000-ton class main battleships. Combined with a high-resolution electro-optical turret, an infrared imaging system, and electronic support measures equipment, the Orca can achieve full-spectrum situational awareness while operating in radio silence. Even in the event of GPS signal loss or communication link interference, it can maintain basic combat functions by relying on inertial navigation and AI-assisted decision-making systems. Of particular note is that the Orca is equipped with a comprehensive autonomous control system. During intensive sea trials, the R&D team focused on validating its capabilities in automatic collision avoidance in complex waterways, dynamic path planning, multi-target coordinated scheduling, and autonomous response during network outages. Leveraging advanced environmental perception algorithms and reinforcement learning models, the Orca has made initial strides in transitioning from remote control to mission-level autonomy. In the future, with the continuous evolution of artificial intelligence technology, the vessel is expected to acquire fully autonomous capabilities in target identification, threat assessment, and attack decision-making, becoming a truly intelligent warship. The Orca is equipped with a standard helicopter landing platform at its stern, capable of supporting the takeoff, landing, and recovery of small and medium-sized unmanned helicopters. This design enables an unmanned surface vessel, plus unmanned aerial vehicle collaborative combat model. Unmanned helicopters can serve as forward reconnaissance nodes, extending the mother vessels beyond line-of-sight sensing capabilities, or carry light weapons to execute precision strike missions. For example, in anti-submarine warfare, UAVs can deploy sonar buoys for wide-area searches. Upon detecting a target, they can guide the Orca to launch anti-submarine missiles or torpedoes, forming an efficient closed-loop strike chain. This integrated sea-air combat architecture significantly enhances the mission flexibility and combat effectiveness of a single vessel. Compared to similar international products, the Orca demonstrates distinct comprehensive advantages. Although the U.S. Navy Sea Hunter is a representative of early unmanned surface vessels, its displacement is only about 140 tons, and it is primarily positioned as a long-endurance anti-submarine tracking platform, lacking substantial firepower. While Turkey's Marin series of unmanned vessels possesses some offensive capabilities, they are mostly small platforms weighing only a few dozen tons, with poor resistance to wind and waves, making them unsuitable for deep-sea missions. With a displacement of nearly 500 tons, the Orca comprehensively surpasses existing small and medium-sized unmanned vessels in terms of stability, endurance, weapon carriage, and information technology capabilities, filling the capability gap between traditional unmanned fast boats and manned frigates. More importantly, the Orca embodies the practical implementation of modern naval concepts such as distributed lethality and manned-unmanned cooperation. In high-intensity naval combat environments, large capital ships are prone to becoming the enemy's primary targets. In contrast, an unmanned wolf pack composed of multiple Orcas can achieve radar signal dilution and the distribution of firepower nodes through dispersed deployment. Even if some units are destroyed, the overall combat network can remain operational. They can serve as forward sentinels, decoy platforms, or extended firepower nodes for manned fleets, executing high-risk missions such as reconnaissance, jamming, and interception in high-risk waters, thereby effectively reducing the risk of personnel casualties. It is foreseeable that as the Orca finalizes its performance specifications and moves toward mass production, it will not only play a pivotal role in the Chinese Navy's unmanned combat system, but is also poised to become a new flagship for China's high-end military export equipment. Its emergence represents not merely a breakthrough in a single weapons platform, but a crucial step forward in China's development of an unmanned and intelligent maritime combat system. In the future, the Orca may join forces with a wider range of unmanned underwater vehicles and unmanned aerial vehicles to form a multidimensional, three-dimensional unmanned combat network, ushering in a new era of maritime warfare.